So you may be thinking, well, what was that? That is to give you a little inspiration for our project. We will be doing a rocket competition where you will launch a rocket that you created. So I wanted to go over um, like an introduction to it and how this is going to work so that you can watch this and then we can spend more time actually working on the project. So what we are going to look at is the chemical reaction between baking soda and vinegar. And when you react those two reactants, you get a product called carbon dioxide. So we are going to use the carbon dioxide from that reaction to fuel and launch our rocket. Okay, that's kind of the basic premise of it. But I want you to look at this. Our objectives for this, there are two goals for this competition. One, you're going to make your rocket out of paper and you want it to go at least 1 meter high. The competition is not about whose rocket can go the highest because all we care about is that it goes at least 1 meter. Any higher than that, it doesn't make a difference. So you have to get it at least over 1 meter, and then this is where the baking soda and vinegar comes in. So objective one, to propel a paper rocket, a vertical distance of 1 meter using a film canister engine fueled with 15 milliliters of vinegar and an amount of baking soda that yields a ratio of rocket mass to baking soda mass equal to or greater than 20 to 1. All right, what does that all mean? So, you'll have your rocket. Everyone will use 15 milliliters of vinegar. What will be different is the rocket itself and the amount of baking soda you use. You want the mass of your rocket compared to the mass of the baking soda you use to be at the very least 20 to 1. So the mass of your rocket is 20 times greater than the mass of your baking soda. That's the starting point. So it needs to go over 1 meter and you need a 20 to 1 ratio of rocket mass to baking soda mass. That's objective one. Objective two is the competition. So what we'll do is we'll have a day set aside where we will launch our rockets. Whoever rocket goes over the meter mark, reaches that meter mark, and has the biggest ratio, so the biggest rocket mass to baking soda mass ratio, will win the competition and gets extra bonus points. Okay? But if you don't fulfill objective one, then you can't be in the running for objective two, which is the contest. So those are the two goals of this project. I want to go through some of the guidelines. Okay? So you will get a manila folder, tape, scissors, markers, balance, pennies, so on and so forth. Only the supplies I give you. The rocket has to be made out of mostly the manila folder. Then you'll get a film canister with a cover, vinegar, baking soda. We'll have a meter stick so that you can measure, tissue paper if you need it. And you must always wear goggles because the caps of the Wyatt, what are you doing? My dog. The caps of the film canisters go flying all over the place, and there's vinegar and baking soda. You don't want a cap in the eye, you don't want vinegar in the eye, so you gotta wear goggles. All right? Those are your materials. So here are the guidelines. For the actual construction of your rocket, has to all be done in class, no outside of class time. You can only use what I provide you, no bringing in other stuff. Okay? The manila folder, which I'll show you what it looks like in class, I wish I brought one, has to be the major part of the rocket. This one is big. Number 4 is huge. Listen, because someone always breaks this. You cannot permanently attach your rocket to your film canister. So no taping, no gluing, no stapling. It has to be, when you give it to me, your film canister and your rocket. Now, when you put your rocket on the film canister, it can fit snugly so that if I hold it, if I shake it or whatever, it doesn't come off, but I have to easily be able to separate them. Okay? Good. So when you're doing your ratio of rocket mass to baking soda mass, it's only the physical rocket. It's not the canister that goes into this ratio. And then number 6, the whole rocket, the bottom of it has to go over the meter mark for full credit. I don't care about the canister and the cover, but the rocket that you make has to, reach that meter mark. So those are the guidelines. Look them over for your rocket, for how to make your rocket and what you can and cannot do. Now, for your fuel, everyone has to use 15 milliliters of vinegar. That will not change. That's the same. What will change from group to group is the amount of baking soda. That's what you're experimenting. How can I change the amount of baking soda? How can I change my rocket to get the biggest rocket mass to baking soda mass ratio? Some people, so number 3 is some people like to put the baking soda in a little piece of tissue paper and drop it in to give them some time. That's fine. But the paper towel does not go towards your mass of baking soda. It's just the baking soda. Okay? When you're launching your canisters, your rockets, there's a tray that I will show you. They have to be launched from the tray. That's our launch pad. It's so people know where it will be, so it's easier to clean up. Okay, it's a designated spot. Number 5 is the most fun. When you are getting ready to launch a rocket, you must yell, "Fire in the hole!" so that people are aware that you're launching it off, because things will be going flying and people don't want to get hit in the head or the eye. Okay? Lastly, you must record data for every trial, even ones that fail. No matter what happens as a result, you have to record your data. Now you say, "Miss D'Angelo, where do I record that data?" Well, looky here, you scroll down. You will record all of that here. Okay? So this is just an introduction to save us some time in class, get you introduced to the project. I will answer any questions and go over this a little bit better in class. I want you to get an idea of what we're doing. It's fun. Have fun with it. Get creative. And I can't wait to see what you come up with. Okay. They recorded.